My name is Amara Yasmine from University of Saad Dahleb of Blida, the electronic department. Glad to present my work about multi-step size perturb and observe for a PV system in the International Conference on Sustainable Energy and Advanced Material. The outline of my presentation is as follows. We start with an introduction, system description and control design. In this section, we will discuss about the solar cell, DC-DC boost converter, controller design, then simulation results. We finish with a conclusion. Introduction. The control of power electronic interfaces converter in photovoltaic systems is ensured using a regulator known as maximum power point tracking technique, namely MPPT. The most widely used in industrial applications is the P&O due to its simple structure and ease of implementation. However, the use of a fixed step size during its operating diminishes the harvested power when a change of the operating conditions appear and leads to significant disturbances. A multi-step size P&O is proposed to ameliorate the conventional P&O with a fixed step size. System description and control design. Solar cell. The basic element of the photovoltaic system is the solar cell, composed of a photogenerator connected to a diode and then a parallel in series resistor. This component is capable of to transfer the light energy of to direct electricity through the photovoltaic effect, and can be mathematically modeled using the equation 1. The connection of several solar cells constitute the PV panel with a high output power. The used system in this simulation contain a PV panel connected to a resistor load through a boost converter. And the switching gate of the boost converter is controlled using the proposed MPPT. DC-DC boost converter. The boost converter allows a voltage value higher than that injected at its input, with the duty cycle obtained using the equation 2 below. The parameters of the boost converter may be obtained using equation 3, 4, and 5 below. Control design. The maximum power point tracking technique is capable to harvest the maximum power from the PV generator. The MPP may be differed in the number of sensors used, complexity, dependence on the system parameters, technique of implementation, and cost. The perturb and the observe started by calculating the power. Then, according to the variation of the power, the duty cycle is either incremented and decremented with a fixed step size. In fact, in our proposed MPPT method, we observe the variation of the delta P if it is higher than 0.85 of the maximum power. A small value of the duty cycle is designed. Otherwise, a large value of the duty cycle, the variation of the duty cycle is selected. Simulation results. The parameters used in the simulation are listed in the table below. In fact, our simulations are done using the MATLAB Simulink platform. Analyzing the system under variable irradiance conditions, applying the curve of the figure 5, we can see that the multi-step size P and O outperform the conventional PO technique. The response time of our proposed technique is around 0.02 seconds. Otherwise, the other conventional technique shows only 0.05 seconds. Analyzing the system under variable temperature, we can apply in the curve of figure 7. When a change of temperature is applied, the proposed techniques still outperform the conventional P&O. The analysis of the curve at each change in temperature, it can be noticed that the extracted power rises with the decrease in temperature, while it exceeds the MPP at 0 degrees C, as shown in figure 8. Analyze under variable irradiance and temperature. Applying a change in both irradiance and temperature, we can see that our proposed technique tracks the MPP with a high efficiency of 99.1%, which outperform the conventional P&O. This latter has only 98% in the performance. Conclusion. The system was successfully modeled and simulated under MATLAB Simulink with variable irradiance and temperature, and under variable variations in both temperature and irradiance. The multi-step size P&O controller effectively extracts the maximum available power from the PV panel. The boost converter steps up the PV voltage to the desired load level. The power loss and the response time are small compared to the conventional P&O, which uses a fixed step size. Future work will focus on validating the proposed technique for a large PV system and grid-connected mode. Thank you for your attention.